still you can come here. And we hope from his idea, especially from his book, God, Nature, and the Cause, basically a collection of essays he wrote on this reviving Kalam as an Islamic approach to science. I think it will be useful for us. And we hope that this will be a kind of ice-breaking or starting point for us to go further, and we also would like to cooperate with National Center for Particle Physics for one to pursue further this issue. So without further ado, I would like to invite Prof. Basil to give his speech.
I am Basil Altaie, Professor of Theoretical Physics at Yarmouk University. I did my PhD in Manchester University in 1978 already, a long time ago. My specialization is quantum field theory in curved space-times. So I worked in this field, and we calculated long time ago the vacuum expectation value for the energy momentum tensor of certain quantum fields in the classical background of Einstein universe, actually. We consider the Einstein universe because of the difficulty in defining a time-dependent vacuum system or a vacuum state. Once you come to consider time dependence, until now, there is a difficulty. And I am surprised that until now, one or two of my very early papers, which were published in Physical Review D78, they are still in citation up to this time. That proves that these are relevant topics to be considered even after all these long years. In fact, since 1989, I started a new interest of mine grew up in Islamic Kalam. This came after my engagement with some topics concerning the philosophy of quantum mechanics. And on one hand, we have problems in interpreting quantum mechanics. For example, the problem of measurements. You know, this interpretation of is very, very, very difficult to suggest. There are many, 4 or 5 interpretations. The dominant one is the collapsing wave function or wave function collapse. But it seems that physicists are not well convinced with any of these interpretations. Recently, maybe in the last 5 years or 10 years, the Bohmian picture of quantum mechanics is coming back again. And many people are getting interested in the Bohmian, etc. There are many things to talk about in this area. And I found that I always have said that, or a question, why particle physics work well when we use group theoretic approach, especially discrete group, and why it fails when we calculate integrals. Divergences appears. In my opinion, it is the dilemma of discreteness and continuity, which is a very, very old philosophical question. Is nature discrete or is nature continuous? I found that the Muslims, the mutakallimun, they're called mutakallimun. Mutakallimun were a group of thinkers who emerged in the 8th century AD, the 2nd century after Hijrah, mostly in Basra and Baghdad and the Abbasid era, during the Abbasid era, the Rhine. And this group of people started very well with discussing natural philosophy problems like space, time, motion, force, etc. Topics in physics. But soon they shifted to discuss the more serious problems according to their estimations, which is related to the Islamic creed. How can you prove or support, at least, Islamic creed with rational proofs, with rational evidence? So they went to discuss the what we call ilahiyat, the topics which are related to divinity and divine action in nature, etc. When they discussed physics, they were doing very well, and they had no problem among themselves. Almost, they agreed on certain principles. Actually, I could distinguish 5 principles that the mutakallimun adopted or devised, rather. They devised these principles as a rival to the Greek philosophy, actually. But when they went into the topic of ilahiyat, the divinity, and hell and heavens, etc., etc., they had severe differences among them, and they were split into several factions. Main 2 factions were the Ash'arite, were the Mu'tazilite first, the Mu'tazili, and the Ash'ari. There they divided. The Mu'tazili were established earlier. The Ash'ari were established later, in the actually around 300 and something, when Abu al-Hasan al-Ash'ari came. The 4th century, early 4th century. The Mu'tazili were in 3rd century after Hijrah. They were well established, the Mu'tazili. Again, I stress that in physical theory, so to speak, they agreed nearly on everything. Nearly everything. Almost. There were some mutakallimun from Mu'tazila, for example, Al-Nazzam, Ibrahim ibn Sayyar al-Nazzam. This guy has very, very innovative ideas. And he was talking about a sort of a leap in motion. So he says, when a particle moves from one point to another, it's not necessary that he passes through the distance between the 2 points, through every bit of the distance. But sometimes he has to jump. And Max Jämer, the philosopher of physics and historian, contemporary philosopher of physics, he died a few years ago, the German national. He says that Al-Nazzam was forerunner for quantum jump. Indeed, in his book, The Philosophy of Quantum Mechanics, page, I think, 159. It's mentioned, anyway, in my book, God, Nature, and the Cause. So, I found that there is much to talk about in physics when I consider Kalam. As I said, Mutakallimun set 5 principles. It's very important to know that in the beginning, before coming to the specific topic of my lecture. I would rather tell you that Mutakallimun devised 5 principles. The first one is the principle of huduth, temporality. They say the universe has a beginning with time. Some people think in time. It's not in time. Beginning with time. This has been made clear by Abu Hamid al-Ghazali in his book, The Incoherence of the Philosophers. And in replying to the question what God was doing before creating the universe, and he said God is not in time because time is created with the universe. Space created with the universe, and this complies very well with the view of the theory of general relativity, as you know, that no space, no time before the existence of the universe. So they say huduth, mabda temporality, huduth. The second principle is discreteness. They say the world is discrete. We see this piece of wood continuous, but if you go in details, it is atomized. And some people think that the Mutakallimun, may think that the Mutakallimun has borrowed this concept of atomism from the Greeks, because we all know that somebody called Democritus invented this notion of atom. But here we have a very significant difference between the Greek atom and the Islamic atom. 2 contemporary or nearly contemporary philosophers and historians of science has discussed this topic. One of them is Shlomo Pins, the Spanish, I think, in his book Islamic Atomism, Studies in Islamic Atomism. He has a book, recently it was translated from German to English, but there is also an Arabic translation much earlier than the English translation. And the other scholar is the well-known Harry Wolfson of Harvard University. In his book, The Philosophy of the Kalam, he devotes 20 pages or so to discuss the difference between the Greek atomism, Indian atomism, and the Muslim atomism. And he admits in the end that Islamic atomism is something new, because Democritus' atom is one piece, one solid piece. Muslim atoms is not like that. Muslim atom is composed of 2 elements. One abstract element called Jawhar. Jawhar is like Schrodinger's wave function. It's the most elementary description, devoid of any specification, any property. Something which is very, very elementary without being specified with any property. And then they have the arad. The jawhar is fixed. It's something which is ready to accept a property, to be a property, which is called the arad. Arad in Arabic means something emergent, something which cannot stay for 2 moments. It changes. So they say our atom, the Islamic atom, is 2 parts. It's the jawhar plus the arad. And this jawhar is not like the Aristotelian substance. The Islamic arad is not like although there's some analogy actually, but it's not the same as the Aristotelian accidents. A jawhar is a jawhar, is an abstract entity defining the most basic constituents of the atom, though such a constituent will not materialize unless accepting arad. So it has to catch a property, like for example color, charge, mass. But if we talk in the mutakallimun, they didn't know charge, they didn't know mass, so they say color, for example, smell also. They can allocate thiqal, the weight. They were not talking about mass. They didn't know the difference between mass and weight. But as it is always was the case before Newtonian mechanics, long ago, they identified this arad as any property that can be acquired by the jawhar. And the arad, as I said, is continuously being recreated. So when you see this red color, for example, they say, this is red, correct, but this red is being created as red. Then the next moment it goes to the next moment, and moment means a blank time, by the way. It's too very, very small time you can imagine. It goes away and comes back again, and it goes away. Creation, recreation, creation, recreation, creation, continuously. As a physicist, I thought when you create position, for example, given a position X, when you recreate position, you have to think of momentum. Because recreating position is actually infinitesimally shifting the function, isn't it? And when you infinitesimally shift the function, you have to do d by dx. And d by dx is momentum, is the momentum operator. So when you create a position x, recreate this x. Once you recreate, you have to have p, operator, I mean. And then you have x and you have p. And then if you further investigate, you find now, or you can understand, the reason for the uncertainty principle. It's recreation. Obviously, you can understand the uncertainty principle, the Heisenberg uncertainty principle, from wave mechanics. And you say it is the wave description of particles which brought in the width of the Gaussian bell, and this width delta x will correspond to delta p in the when you make a Fourier transform, so that delta p with delta multiplied by delta x will give you h bar or something of order of h bar. Yeah, correct? But the more fundamental description is to say that the mass of the electron does not remain constant as it is. Because in this picture of the recreation, Islamic notion of recreation, you can also understand what's the meaning of to have many eigenvalues for the same system. Why it does shift from the Gaussian average by delta x or delta p or delta e or delta t, etc. Why should it? Why? Because upon recreation, you always shift something. It's not always recreated with the same eigenvalue. Simply because states do not stay in the same state. A state is ever changing, you see. If it will persist in the very same state, then there is no change, actually. You can say continuously. Mind you, you are talking about a very, very, very small time. It approaches the blank time. We are not talking about transitions occurring in 10 to the power minus 7 seconds, or minus 11 seconds, or even minus 22. For an electron, it will be something like 10 to the power 21, actually, minus 21 second. And this is a very short time. It's about the transition time between two levels, etc. In any case, this discreteness is a very rich subject for studies, even in the interdisciplinary field, even by particle physics. And I feel it suggests a very good, feasible, rational solution to the problem of measurement in quantum mechanics. It can explain, in my opinion, the question of entanglement, quantum entanglement, etc. And also I have a paper which is in archive, well, it was published actually in a conference proceeding. I could also predict macroscopic quantum states. Obviously, we do have macroscopic quantum states in, for example, Bose-Einstein condensation, and we have it also in laser, the macroscopic. But I still think that there are much room to talk about macroscopic quantum states in stars and near black holes, very near to the event horizon. I expect to, and this comes from Kalam. Kalam suggests this. Anyway, the third principle, as I said, so the first principle is Huduth, temporality. Second, atomism. The third I already talked about, which is recreation. And the fourth is the probabilistic nature of the probabilistic nature, yes, of natural events. Mutakallimun thought that if you throw anything, it will fall, okay, but there is a chance that it will not fall. No matter how small is this chance. Could be very, very small. But there is a chance. And what this is quantum mechanics tells us, that there is no absolute 100% probability in expecting the free fall, even for a macroscopic body. When you go to microscopic bodies, microscopic systems rather, in crystals, etc., the probabilistic nature is well manifested, as we know, without which we can't have cell phones, for example, mobile phones. Your mobile contains hundreds of thousands of crystals inside which there are electrons penetrating the walls of the crystal, the potential, despite that the energy of the electron is less than the wall, the strength of the wall. But this is called tunneling effect. All microscopic systems manifest such probabilistic behavior, and probability get high. The fifth principle is space-time. The Mutakallimun talked about the existence of space-time with the universe, plus the most important thing, they said space has no meaning without time, and time has no meaning without space. And Abu Hamid al-Ghazali, in his book Tahafut al-Falasifa, he also talks about the time dimension, and he equates it to the space or the spatial dimension. There is a very good English translation of Tahafut al-Falasifa, which he uses time extension. But in Arabic, if you go to Arabic, text, you will see that Abu Hamid is talking about al-bu'd al-zamani wal-bu'd al-makani, and he says fal-bu'd al-zamani kal-bu'd al-makani. Exactly the same. Ibn Hazm before Al-Ghazali, about 200 years, less than 20, before Al-Ghazali, rejected the philosophers' absolute space and absolute time. In his book, Al-Fisal fil Milal wal Nihal. Al-Fisal fil Milal wal Nihal is a book actually about the different factions of thoughts. Anyway, I feel this introduction is necessary to come now to the main topic of this, because we have to understand divine action later of this lecture. Good. Why I'm eager to discuss, this one. Why I'm eager to discuss the question of the question of laws of physics and laws of nature. You are living in a Muslim country, by the way, and perhaps you should be more aware of this fact, that physicists, including top physicists like Stephen Hawking, Paul Davies, and many others, are using the term law of nature to mean law of physics and vice versa. In the context of science and religion, this leads to confusion. In understanding nature, this leads to confusion. Why? There are confusions which for example, Paul Davies in his book, The Mind of God, or other books, he says, given the laws of physics, the universe can pop into being without the need of God, for example. Lawrence Krauss, the cosmologist, says the same thing in his book, A Universe Out of Nothing, as a recently published book. Stephen Hawking sometimes in his TV interviews, and he says, I can't see the reason why one should think of a creator. A creator is redundant. Since we can, starting from vacuum, quantum vacuum, considering the quantum fluctuations, we can create a universe. How? By gravity. Mind you, Hawking does not question where gravity comes from. He may say curved space-time, okay, but who curved this space-time? In a Minkowski space-time, as you well know, you particle physics do not consider the effect of curvature in your calculation, as far as I know, unless you go to quantum gravity. In fact, before going to quantum gravity, you can go to the semi-classical approximation, what we call the semi-classical approximation, by which you take the gravitational force as a classical field and the quantum, quantum field, you take it quantized. So you take the expectation value, vacuum expectation value, on the right-hand side of Einstein field equation. But then the question comes, why gravity? Where from is coming gravity? If vacuum, between two brackets we say nothing, the physical nothing, may need no creator, because it's nothing, simple. How could, or who, or how could we have gravity without a creator? In the Einstein view, it's a curvature of space-time. Who has curved the space-time? Who created applied such a curvature? Unfortunately, I couldn't find an answer from Stephen Hawking. But the question remains to be posed. So this leads to confusion, actually. For example, we attribute the creation of the universe, events, to laws of physics, while laws of physics are our own mind, our own imagination. Yeah. This has implications in causality also, which I will deliver in the afternoon. I will talk about it also in the afternoon. So they say, no need for a creator and no need for a force to sustain this universe. It is all laws of physics. In fact, laws of nature are the phenomena that takes place without specifying any interpretation. It's the phenomena. For example, I see the solar eclipse. And I don't know anything about physics. I don't know even that the sun, the moon is revolving around the earth. I don't have such an idea, for example. The eclipse itself, as it is a natural law. It's periodic. One important property of the natural law of nature, because natural law may be used in economics and legal affairs. So better talk about law of nature. When you go to the laws of physics, for example, as I said, solar eclipse or burning a cotton or a paper, when you set it on fire, it will burn. This is a law. Freezing of water is a law of nature. I don't know what are the reasons. I don't know what molecules are doing, etc. I know water is freezing when it comes at certain temperature, low temperature. And I call this is a freezing point. Law of nature are immutable. They do not change. Laws of nature are part of the construction of the universe. And they are indeterministic, as we know from quantum mechanics. As I said a few minutes ago, what we have, according to quantum mechanics, events in nature do not occur deterministically. They are indeterminate. No event can have 100% probability to occur. Therefore, laws of nature cannot act by themselves. They cannot have the ability to act because they are indeterministic in the first place. Laws of physics are our own imagination or our own understanding of the phenomena taking place. For example, when we see two bodies, for example, as I said, when I throw a piece from my hand, falls, and we say, aha. Mr. Newton tells us that there is a mutual force between the two bodies. And this force is inversely proportional to the square of the distance between the centers of the two bodies and is directly proportional to the masses, multiplication of the masses. But then 250 years later, somebody else called Mr. Einstein comes and says, oh, this is all wrong. This picture of mutual attraction, etc., is wrong. Also in mathematics, this law is only an approximation. It's not the correct value. What is it, Mr. Einstein? And he would say it's a curvature of space-time, which causes, it's the curvature which causes planets to move around the sun. It's not the mutual attraction force like a rope tying both ends. It's not like that. Or a string. It's not a string. Gravity is the curvature of space-time. Theory completely changes. Calculation changes also. And we discover later that calculation-wise, the Newtonian mechanics and his results when we calculate gravity are only first approximation of the general relativity, general theory of relativity, general theory of calculations. Correct? Therefore, laws of physics are not fixed. Somebody else may come in 10 years' time from now and propose, we have already many other alternative theories of gravity. And he presents a new theory, new laws of physics. But law of nature is the same. The law of nature remains the same. It is our explanation for the law of nature which is suggesting to us a law of physics. What is the importance of the law? The law, the most fundamental property of a law is to be periodic. Without a law, we cannot talk about organized or ordered universe. Certainly. Certainly. This suggests the need for a creator, including what I said, indeterministic nature, means you have set of probabilities, set of eigenvalues, using your terminology of particle physicists. There are certain eigenvalues. Each has allocated a probability. But when such a probability will occur, nobody can tell you. A physicist cannot tell you when this or that value will occur. They can only say, aha, we have this values, 3 or 4 or 10 values, and each has a given probability. Sometimes very low probability, sometimes very high probability. But then, when this low probability, could it happen with a low probability? Yes, of course. This interaction may take place, although it is a low probability event. For example, in the sun, when during after the helium burning, you can actually add 3 helium atoms to make carbon. And then you can add a 4th helium atom to make oxygen. Astrophysicists, quantum mechanics knows that this is a very, very low probability event. But it occurs with high percentage. Why? There is a sort of resonance. Although it's a low probability event in less than 0.1%, by the way. But it occurs. It happens. Therefore, somebody has to choose between probabilities. Some agency. I don't know. I wouldn't say God. But we call him God. That's it. It's a transcendental agency. I don't need to go in details and specifying his properties, etc. It's something else. This is Jalil al-Kalam. Daqiq al-Kalam, the fine Kalam, the natural Kalam, will specify to you the need for a creator, the need for an organizer, and a need for a sustainer. Because this universe has to be sustained, according to Mutakallimun, being under continuous change. There is one interesting philosopher. She is American origin, but working in Britain for a long time now. Nancy Cartwright. She has a paper, well-known published paper, in which he shows that if there is no God, then there is no law. And this is the title of the paper. No God, no law. I'm not sure she is a theist. I'm not sure whether she is a theist. Perhaps she is not a theist even. But as a matter of philosophical interest, no law, no God. No God, no law, sorry. As you know, this is the deterministic universe of Laplace, based on Newtonian physics, and we have a mechanical universe. This has ended long ago, actually, in the beginning of last century. We have modern physics. In modern physics, we have wave-particle duality. They discovered that particles are not exactly particles, and waves are not exactly waves. They are somewhere in between. Waves exhibit properties of particles, and particles exhibit properties of waves, and this is was actually formulated by the de Broglie relation, lambda equal h over p. And since then, physicists interested in this new picture, accordingly, Erwin Schrödinger was able to formulate his basic non-relativistic equation of motion in quantum mechanics, which is called Schrödinger equations. The two equations, time-dependent and time-independent Schrödinger equation, which were later on, Paul Dirac was able, before Dirac, Klein and Gordon, actually, Klein-Gordon equation, they formulated the first relativistic equation for the equation of motion in quantum mechanics, which applies to scalar particles, I believe, the Klein-Gordon equation. And then later on, Dirac devised the genius description of relativistic quantum mechanics formulated in his equation of motion, Dirac equation. So, and whatever we have from the technology, present technology among us, is all products of modern physics. Our cell phones will not work, mobile phones will not work with the Newtonian description, classical, mechanical, thermal description, as we know. Even lasers, of course, are a result of this new mechanics, new modern physics. What are the implications? Main implications of quantum mechanics in deterministic nature. Events are possible, contingent, we say, in philosophy, but not deterministic. Causes may be present, are there, but no event take place. Conditions can be made available for burning a cotton, for example. I'm taking a macroscopic example but on the microscopic level, it is very well exhibited, shown, demonstrated in the microscopic event. Causes may be present, but no event take place. Also, what is the initial cause of the existence of this universe? Even those who are talking about this universe being created out of nothing, without any cause, they still are questioning the cause, the initial singularity, so-called initial singularity, and why it is there. Science has no answer. There are uncaused events in the literal sense of a cause. By the way, mutakallimun accepted that there are causal relationships, but they denied deterministic causality. And this has to be clarified, because you may read in many books, including books written by Arabs, that they say the mutakallimun, especially the Ash'arite rejected causality. This is not true. None of the Ash'arite rejected causality as such. They rejected deterministic causality. And by the way, both the Mu'tazilite and the Ash'arite, the Mu'tazili and the Ash'ari, both agreed on this description, that causal relationship exists, but deterministic causality do not exist. Is not correct. Obviously, you may say to me, oh, Dr. Altaie, but you have to be reminded of one important factor, and that is their derivation of such a concept comes from religion. Yes, I don't deny that. I don't claim that the Muslim mutakallimun had a physical theory developed from natural resources or natural vision. Guidance was from the Quran, no doubt. They read the simple verse, Allahu la ilaha illa huwa al-hayyul qayyum. Qayyum in Arabic means sustainer. They believe in a God who is live, active, all the time. How God will act if we would think that laws of nature, or what we act on their own, deterministically. If laws of nature act on their own deterministically, there is no need to God. This is the first, actually, premise. Although one may say, still there is a need for God. Yes, I know. But let us stick to this elementary level of identifying the case, and we say, if laws of nature act deterministically, there is no indeterminism completely, you don't have a need to somebody to choose between probabilities. And by the way, this is a very important point, which if you go ahead, you find it will lead you to a chaotic universe. A universe without God is a chaotic universe. In the first premise. But if you go deeper, and you can even talk about anything existing without God. Even the chaos would not exist without. There are some physicists. Paul Davies was a friend of my supervisor, Stewart Dowker, in the second half of the 70s. And he was used to visit my supervisor from time to time. I met him several times, and we had a little chat once about the laws of physics and the mind of God. And I gather that he had the idea of this book. It's actually a book named The Mind of God. He believes that what we discover in nature, law of gravity, law of thermodynamics, law of entropy, etc., are all implanted in the mind of God, these laws. So he sees as far as I understand, that when we investigate nature and discover such laws, we are discovering the mind of God. This is wrong. Completely wrong. Because as I said earlier and showed earlier, that when we discover a new law of quantum gravity, for example, somebody else may come in 10 years' time and change the law. Does this mean that the mind of God is changing? When Einstein changed the Newtonian gravity completely, conceptually and calculation-wise, I know weak gravity will comply with the Newtonian, but if you go to the basic concept of Newtonian gravity, you see action at a distance. And you go to the basic concept of Einsteinian gravity, you see curvature of space-time. It's two different things. Gravity, according to Newton, propagates with infinite speed, while gravity, according to the Einsteinian description, it propagates only with the velocity of light. John Polkinghorne, an atheist, he says, but well, God is a sustainer, but he is not a puppeteer. He's not playing with the universe as a... Well, could be. Is always there is the question of free will, by the way, and the free will comes in my opinion, in living, cautious individuals. Here we can have free will. Yeah. Divine action. God has created the world with truth and justice according to the Islamic understanding. Sorry. This means that it follows law and order. خلق السماوات والأرض بالحق تعالى عما يشركون. In what I understand بالحق, it means by a law. To follow a law. بالحق. Because حق is the truth in one. It's justice in one another interpretation of the word. But how can you establish justice without having a balance or a reference? What is the reference? It has to be a law. God respects his creation, and that is how law and order comes. Accordingly, when God intervenes in the world, he does so through laws driven by him, And what are these laws? They are not the laws of physics. They are the laws of nature, as we have shown. Cotton burns when when thrown into fire. This is the natural law, without specifying any molecular structure, etc., etc., etc. It's just the phenomena itself is a law of nature. And law of nature and the phenomena in nature are probabilistic, indeterministic. So this is سنة الله التي قد خلت من قبل ولن تجد لسنة الله تبديلا. The law of nature is immutable. ولن تجد لسنة الله تبديلا. That's why I call the law of nature sunnah, and I call the nature itself of things as fitra. فطرة الله التي فطر الناس عليها, for example, is fitra. It's a new term. How it works, in my opinion, divine action can be understood through recreation, as I explained. Mutakallimun devised this principle to justify the continuous act of God, as I said, because he is qayyum. To be qayyum, laws of nature has to be indeterministic, and this agrees with quantum mechanics, as we said. متكلمون devised this principle to justify the continuous act of God to sustain the world. الله لا إله إلا هو الحي القيوم. Now at this age, we can understand this principle with deeper implications. As physical parameters are recreated, as I explained this already, it affects a conjugate parameter. For example, if you recreate position, you should expect generation of momentum, and vice versa. For example, yes, recreating the position. This also can explain the foundation of Heisenberg's uncertainty principle. I already explained that in the context of the second or the third principle of Kalam. And as I told you, the recreation principle can explain many problems in quantum mechanics, including the measurement theory, the double slit experiment, you know, the famous Feynman says, I can't understand the quantum mechanics. How the hell two electrons come, or two photons come through the two slits at the same time? The recreation principle can explain that. It tells you that the two photons or two electrons, let's consider, are under continuous recreation. Recreation time is 10 to the power minus 22 or 21 seconds. 10 to the power minus 22. If you calculate, by the way, within your measurement time is too long compared to the recreation time. Your measurement time is too long, again, compared to the recreation time. Therefore, an electron passes through here. Another electron is created there in slit number 2. And the third electron is slit number 1. And a fourth electron is recreated. State of the electron is flipping between the two. And within your measurement time, when you look at what is happening, you see the electron is passing through the two slits at the same time. But the word at the same time is always associated with the duration you are talking about. You should look at the duration and compare that with the recreation time of the electron. And yes, if you can go shorter and shorter time, you will discover that it's not going actually through two slits, it's going through one of the two slits. But then they will say, if I do that, practically, the interference pattern will disappear because you have an interaction between you and the observer and the beam. So you destroy, or in their terminology they say, wave function will collapse immediately. The quantum mechanical phenomena will disappear, etc. But then we can discuss this also in details. I feel it's possible, and the wave function collapse is not the only explanation available for such events. Recreation explanation is a better, more rationalistic explanation of such quantum behavior. I think I should stop here. Thank you for listening to me, and I am ready now to questions or any comments.
You said, you mentioned of the need of an organizer.
Yeah.
Okay. But of course, in biology, this is, you know, they explain this in terms of evolutionary theory that, you know, things sort of, the fitter systems would be more organized.
Yeah.
And so the organization comes from the survival of the fittest.
Yeah. That all laws of nature needs a driver, because laws of nature, I hope you figured my argument. Since physics tells us that the quantum mechanics tells us that laws of nature are indeterministic, therefore they cannot have their action or the acts needed. So even when two molecules combine together to get a more complex, in biology, a complex molecule, somebody, an agency has to push this act. I don't know whether I have mentioned this. A driver. We need a driver. We need, for all laws of physics, including the substratum of biology, which is laws of physics again, chemistry, biochemistry. Who is putting the biochemistry on action? A transcendental, it has to be a transcendental agency, because, as we said, if one would say, well, one day we may discover a law of nature that is dominating all laws and ordering the laws to work. This law, if it is part of the set of laws of nature, it will need a driver again, ad infinitum. Therefore, such a law has to be transcendental. As I said, we call him God. You can call him anything you like. Because I only want to convince you that there is a transcendental agency not belonging to this universe. So organization itself needs a driver in the very beginning by driving the laws causing complex combinations from simpler ones. I hope this will answer your question.
If I can just interject. If I'm not mistaken, you mentioned this point under the frame of Kalam cosmological argument revised by Craig, right?
Yes.
In the book.
Yes, I mentioned in the book, in my book, that Kalam, that William Craig, who is American philosopher, actually reiterated Al-Ghazali's principle of the Kalam cosmological, and he called it Kalam cosmological principle. Al-Ghazali said very simple words. He said it in very simple words. Everything which has a beginning, which begins to exist, must have a cause. And the universe began to exist. Therefore, it must have a cause. And then William Craig goes on to show that such a cause cannot be member of the group of the laws of physics or laws of nature, and therefore it is transcendental. It's in parallel actually to my argument here. Yeah.
So he was actually agreeing to the Kalam.
Oh yes.
Not.
Oh yes. I have written to William Craig, and I told him, you are talking about one of the principles of Kalam, of Daqiq al-Kalam. In fact, there are other 4 principles. And he said, I am sorry, I am not aware of the other 4 principles. In short, he answered me, saying, I am not aware that there are such principles. But this was before writing my book, the Daqiq al-Kalam, the Islamic approach to natural philosophy. I will send him a copy, I hope, once the book is published. The book will be published, I hope, in the next few months. It's a big book, including some biological topics I have discussed, by the way. I have discussed in one chapter in this book, Daqiq al-Kalam, I discussed evolution, the Darwinian evolution and non-Darwinian evolution, I believe evolution is correct, no doubt, evolution. But the theory, the Darwinian theory of evolution, in my opinion, has big loopholes, especially when talking about random mutation. I believe in adaptive mutation. It's more realistic.
I have many questions. But,
Yeah. Well, start with the most important ones, because we have to.
the first one is about this, because the topic is about laws of nature, laws of physics.
Yes.
You differentiate between the two.
Of course.
I realize that there are similarities between your arguments with the positions taken by philosophers of science or physicists themselves with regard to realism, the philosophical position of realism vis-a-vis the others, like nominalism.
That's right. That's right.
Perhaps the most prominent philosopher is Immanuel Kant, who mentioned this separation between phenomena and noumena. That you can always arrive, you can always attempt to have a more and more precise account of reality of the phenomena.
Correct.
But you can never attain to the noumena, the things in themselves. So that was the position of Kant. Like Abraham, the philosopher of science, mentioned that the whole scientific enterprise, the whole physics enterprise as a research program that began perhaps with Plato or Pythagoras is to give description of the appearances, say the appearances you mentioned. But so in order to do
Not
that,
to the actual reality, yes.
So we always construct models.
Correct.
So that is the extent of our knowledge.
Correct. Correct.
So the issue between the scientists and their confusion between laws of nature and laws of physics perhaps stems from their rejection of anything that cannot be ascribed via the epistemology.
Yes.
And because of that, it seems to me that nothing that can be said from our perspective that can convince them otherwise. If so far as they hold on to that principle. I think you mentioned also in your book that it is something that they equate epistemology and ontology, something like that. Perhaps you can comment on that.
On the ontology, sorry?
No, I mean, I believe, if I'm not mistaken, you mentioned in your book somewhere that these positions of the atheists, scientists and philosophers is that they reduce ontology to epistemology.
Correct.
Something like that. Therefore, what can we say? There's nothing that we can say to them that could convince them otherwise unless they change that position.
First of all, let me comment on what you said. In fact, there is a section in this chapter about laws of physics and laws of nature. In the book, there is a section titled Logic, Mathematics, and Reality. And what you just said has been discussed in the pages that follows, actually. And then I go into discussing conservation laws and how it was discovered, how they were discovered. And this comes into what you said is correct. It's a philosophical. Philosophers knows about this thing better than physicists. That's why physicists, prominent physicists, were in error when they said laws of physics can create the universe, etc. They cannot say even laws of nature can create the universe, because as I said, the laws of nature needs a driver. Laws of physics cannot do anything at all. Laws of physics are description. But concerning ontology, I think I came across reducing ontology to epistemology. I came across it when discussed the notion of atom in Islamic description. And I said that the jawhar is an epistemological. I think where I It's an epistemological entity rather than an Jawhar itself. The Jawhar itself, if you like, substance in the Aristotelian term, but not in the Aristotelian sense, is different. It's an epistemological entity. However, Jawhar, according to Mutakallimun, cannot exist unless acquiring arad, a property, would not materialize. Therefore, I can only understand that the Jawhar exists as an epistemology. An epistemology. So when we talk in theological terms, we can say, for example, that the whole world was known to God. Known. في علم الله. And then it was converted from a notion, an idea, and whatever you like. It's difficult to say idea of God. I don't like these terms. Because when you talk about God, you should be very sensitive, very careful, not to follow the old kalam methodology and terminology, and you fall in problems. Because one of the main problems which made people hate kalam in the past is going through something which is going through discussing topics and using terminologies which are not acceptable to the pure Islamic creed. That's why they had problems, by the way. Now in the new kalam I am suggesting, we avoid getting into such topics. For example, discussing the divine properties or divine sifat, attributes, divine attributes. The chapter of divine attributes in the old kalam makes hundreds of pages. The chapter of the same chapter in the new kalam makes only few pages, less than 10 pages. Because we take it as it is in the revelation, in the Quran. Allah subhanahu wa ta'ala has a knowledge. We don't dig too much. How is the knowledge of God? Allah Sami', Basir, etc. We don't say, does he see with an eye? What sort of an eye he has? Allahu Qawi, does he has hand? وَالسَّمَاءَ بَنَيْنَاهَا بِأَيْدٍ وَإِنَّ Does God has hands? The Quran says بِأَيْدٍ. And we say all this, we take it as it is in the Quran. And we understand that hand is a force, is a capability, is ability. Stop, full stop. We don't get into details. Because going into the details in a field full of minds would cause problems, you know. And will lead us nowhere. So in my opinion, the philosophical thinking you were talking about is correct. Yes, but it should have certain limits. And the limit is the region of validity, range of validity. Even theories of physics has a range of validity. Correct? So philosophical thinking should have a range of validity too.
Well, my question is on observer effect. I reckon you mentioned something on the double slit experiment. Now, under one, the question would be, how would you explain this from religious or from Kalam perspective? I really have no knowledge on that, and I would really wish to know more how that could be explained from Kalam perspective. And number two is, like, since this experiment happened and it was a big boom, like, trying to say that, oh, this is going to change everything and all that, I don't think much development has happened on
Is electron ontology or epistemology? Actually, it's both. When you write to me the Schrödinger wave function of the electron, or even the Dirac wave function, never mind. When you write the Dirac wave function for the electron, or the wave function, it is epistemology. All physicists know, when you ask a physicist, is the wave function psi a physical entity, a physical thing? We say no. It's not physical. Because it can be complex. Complex means real part, imaginary part. Imaginary part means square root of -1. Therefore, it's not measurable. A physical object has to be measurable. So when you ask me, is the electron wave function an ontology or not? I say no. It's not ontology. It's pure epistemology. And when we come here to the young lady's question about the observer effect, I don't see that the observer effect has any ontological presence, in my opinion. No experiment tells us. They claim, in theory, they claim that there is, for example, John Wheeler claims that there is even a late time observer effect. That's what the theory generates. It's a theoretical artifact. The Two Slits Experiment, again, is another. When you see the Feynman tells us that the electron is passing through the two slits at the same time, this is only epistemology. Because your same time is 10 to the power, say, -4 or -6 seconds, while the actual time which you should consider is less than 10 to the power -21 seconds. Then you will see the proper ontology in that case. Beyond that, it's epistemology. I don't see the atoms of this wood. So in fact, the atoms of this piece of wood are epistemology. It's generated by my theory to explain the behavior of the world. I generated the idea of atoms. And I said there are two different pictures, fundamental pictures, even within the epistemology of the atom, the Greek atom and the Islamic atom. Fundamental difference. But how can epistemology help us? Again, another question by the young lady. In understanding the world, do we have limits in this or that? Yes, of course, always, as long as we dwell into, we go deep into trying to understand the abstract, we are actually converting what is in epistemology into ontology by showing or demonstrating, as they say in philosophy, and in physics they say prove, that such theories can be verified. So certain theories, for example, again, the Einstein-Podolsky-Rosen conjecture of the entangled states in 1935. It's only epistemology. That there is a sort of entanglement between a positron and an electron being created out of the same beam, of the same gamma ray beam, and you throw them one to the east, one to the west, billions of light years away, and they are entangled. connected. Epistemology, because our theory of physics cannot accept conveying information with a speed more than the speed of light. In this theoretical conjecture, it says the information will be converted with a speed higher than the speed of light. That's why Einstein, Podolsky, and Rosen concluded that quantum mechanics, therefore, quantum mechanics is incomplete. They didn't say wrong. The theory is wrong. They say it's incomplete. Because there is nothing like that in ontology. You see the point? So they concluded from epistemological arguments, they declared the verdict that quantum mechanics is incomplete. While in 1982, Alain Aspect, the French physicist, proved in laboratory that entanglement do exist ontologically. This is a piece which we see ontology being converted, epistemology being converted, being realized as an ontological state. Same apply, of course, I hope, I don't say of course, no, I hope, on semantics, etc., psychology, although I cannot guarantee that because I am not expert in this field of specialties. But I expect that there are certain behavior which can materialize into real behavior in life, already conjectured or predicted by some theories. I hope this will be inspiring, is it?
One more question.
This is about the between indeterministic and deterministic causality. But if quantum states, the Copenhagen interpretation, wave function collapse into the eigenvalues and the functions and the respective probabilities.
Yeah, this is epistemology too. Yes.
But we see it happens in the double slit experiment. So
Nobody see the wave function collapsing.
Okay, not the wave function collapse, but the result of the...
Yeah, the interpretation, yeah.
Well, apparently to me, when I read your book, you interpret this as to indicate in the indeterministic causality that the cause does not necessarily produce an effect.
The same effect,
Same
yes.
effect at the time. And therefore, the need for an agent to choose
Between the...
all these
Yes,
possibilities.
yes, yes.
But having said that, the whole theory of causality also relies upon the perspective probability function.
Of course.
So the question is this agent necessarily follows the probability distribution, or is it able to transcend or to not abide by the probability distribution?
No, he has to respect the law of probability. It's part of his creation. This is sunnah, the sunnat Allah, as we said. But choosing between the probability is his own business. What do you mean abide? What do you mean by
Yeah.
many
Many times
Not necessarily many times. It could go to the lowest probability from the first shot. That's what happens in physics. You can go to a low probabilistic event from very few shots, or the first shot even. There is nothing preventing a low probability event to occur in the first shot. For example, if you have a dice and you play the dice, there is nothing preventing you from having a number coming back, although it's 1/36 probability. Next shot you get the same number. But then you cannot do that 10 times. Otherwise you will break the natural probability distribution. You see my point? I hope you get my point. That low probability event is not restricted, an event restricted to a very large number of shots. It could be the first shot you get a low probability event, in the first shot. And who knows that? Who knows when the low probability event will occur? Nobody. Do we have a law in physics controlling such a behavior? No. We only have the law distributing the probability. Yeah?
Okay, does that mean that it is possible for a beam of beta rays to pass through a differential gradient and not produce the interference pattern?
It could be. Yeah. In theory, it could be. How it happens, how many times it happens, I don't know. Nobody knows, actually. Yeah.
So, Prof, me maybe my last question.
Yeah. So we are within the time.
You are proposing a new kind of framework of approach using Kalam. How do you think this approach will change our way of viewing science now? And what direction this Kalam approach will lead us?
I'm sorry, which?
Yeah. How your approach will change the way we are doing science now?
The way doing science.
What direction will
Yeah, it will not change science. Science is a mainstream that is going according to certain principles and approach. Science is an approach rather than, it's an approach to discover nature. As simple as that. How Kalam or Daqiq al-Kalam, new Daqiq al-Kalam will change, it will open our eyes on areas which were not in our agenda. That's all. But we will still follow the same methodology of science. We have to investigate according to scientific means, verification, and we should verify, we should prove true or false. We should always adopt observations, experiments as a measure for the success of our theories. If observation says no, then we will say no to our theory. But only we have to keep an eye on other areas, and also we should not deterministically say this is the final answer. There is no final answer in science. We should not be in a hurry and we say, therefore, we don't have a creator. We don't need a creator. I prove that, for example, I prove that the universe can exist in imaginary time before creation, and infinite imaginary time, like what Hawking and William Hartle and Hawking did in 1983, I think. And they concluded that, therefore, there is no creator. because there is no beginning to the universe. Who knows? Moreover, you are talking about imaginary time. The universe has been existing for infinite imaginary time before creation, before being realized. Well, it was epistemology. Because imaginary time is not measurable. It's not physical time. Therefore, it's not ontology. It's not ontologically existing thing. It's the idea in the mind of God. Here we can say the universe could have been an idea in the mind of God, having the square root of -1. It's epistemology. It was converted, really created, when it became to exist. Therefore, we still need a creator, at least to convert the imaginary time into real time. At least. No event happens without a cause. That's what Mutakallimun says. Although many authors say Mutakallimun do not believe in causality. This is wrong. They believe in causality, but they do not believe in deterministic causality. This has to be clarified. So, Doctor, we have a new era, new areas to discuss, new vision, by the way, wider vision than. But as far as the approach will be the same. Science is science. I don't want to impose religion on science. Never. Never. Science should have freedom to approach in investigating nature the way it does. Interpretations will be different. Yes. When you introduce Kalam. Vision will be wider. Thank you.